In question 3, we have a deep space probe which is travelling through space in a straight line at 160 meters per second and has a total mass of 500 kilograms. It then ejects a capsule of mass 150 kilograms explosively, releasing energy. After the explosion, the probe, now of mass 350 kilograms, continues to travel in the original straight line, but at 240 meters per second. In A, we need to discuss how the principles of conservation of momentum and conservation of energy apply in this case. Well, momentum is always conserved in an isolated system. This is an isolated system, so the momentum of the probe and capsule before the explosion must equal the combined momentum of the two after the explosion. The probe gains momentum in the original direction, the capsule loses momentum in the original direction. Energy is conserved in all situations, but energy can be transferred from one form to another. In the explosion, some of the chemical energy is transferred to kinetic energy of the probe and capsule. Therefore, the total kinetic energy will be greater after the explosion. In B part 1, we need to find the magnitude of the velocity of the capsule immediately after the explosion, stating its direction. Well, momentum before equals momentum after, and the momentum before is 500 kilograms at 160 meters per second. Momentum after is the 350 kilograms of the probe times its 240 meters per second, plus the 150 kilograms of the capsule times its velocity. Rearranging for the velocity, we get minus 26.7 meters per second. The minus sign tells us the direction is opposite to the original direction, therefore to the left in the diagram. In part 2, we need to find the energy given to the probe and capsule by the explosion. Well, this will be given by the kinetic energy after minus the kinetic energy before. So here the kinetic energy of the probe plus the kinetic energy of the capsule after the explosion minus the kinetic energy of the probe and capsule before the explosion. Putting in all the values gives 3.7 times 10 to the 6 joules.